So up until now, we have had a function like 2x plus 1 squared to differentiate. We prepared to differentiate by multiplying out the brackets first. That's simplified before we differentiated. That was our preparing. But how could we differentiate f of x equals 2x plus 1 cubed? So we're starting to get a little bit more difficult. Now with no other knowledge, I'm quite sure you'd be able then to take your 2x plus 1 cubed and then split that up into separate brackets. So 2x plus 1 squared times 2x plus 1. And then preparing, we've got 4x squared plus 4x plus 1 times 2x plus 1. Multiplying out the brackets, 8x cubed plus 4x squared plus 8x squared plus 4x plus 2x plus 1. And we can simplify that to 8x cubed plus 12x squared plus 6x plus 1. There's been a little bit of work done there, but it's not impossible. You've got the skills, you could do it. That's us just preparing to differentiate. I've got f of x equals. I've not actually differentiated. I've had to put a whole pile of work into that first. So now we can differentiate each term individually. That gives me 24x squared plus 24x plus 6. Remember, when we differentiate a constant, it vanishes. Now I could leave it like that, or I could recognise, well, hold on a minute, there's a common factor here. So let me factorise it, let me simplify it. So I take out a factor of 6. That gives me 4x squared plus 4x plus 1. Now wait a minute, up the top we've seen that already. That's just 2x plus 1 times 2x plus 1. That's just 2x plus 1 squared. Now that's not normally necessary, but I've done that today to simplify it, to say, well, wait a minute. When we differentiate f of x equals 2x plus 1 cubed, the final answer looks very similar. It's 6 times 2x plus 1 squared. It's not a million miles away. So I'm thinking, if we look for a pattern, can we find a shortcut? Can we find a new rule? Okay, guess it's going to be called the chain rule, guys. Let's have another look. So preparing to differentiate by multiplying out the brackets will become very complicated when we have powers higher than 3. So as I said, let's look for a pattern to help simplify the process. This is what all mathematicians do. So f of x equals 2x plus 1 cubed, f dash of x equals 6, 2x plus 1 squared. Now I'm just going to give you a pile of answers. Can you see a pattern evolving? So if I tell you that if I differentiate the function f of x equals 5x plus 2 to the power 4, I get the function f dash x equals 20, 5x plus 2 cubed. Another one, if f of x equals 7x minus 4 to the power 10, f dash x equals 70 times 7x minus 4 to the power 9. Another one, f of x equals 3x minus 17 to the power 100. Definitely can't multiply out those brackets. I'm telling you that f dash x equals 300, 3x minus 1 to the power 99. Can you see a pattern evolving? Can you work out what possibly we could do here? What is the chain rule? So can you see a pattern? Nope, we'll try differentiating outside the brackets. Then the function inside the bracket and multiply them together. That's basically the chain rule. Right, not sure what I'm talking about. Let's try some examples. The chain rule. So when we are differentiating composite functions, we use the chain rule. That's a bit blurry, but that's what's in your textbooks. Okay, so we've got a composite function, f of g of x. Okay, we can split that up into the derivative of the first function times g dash x, the derivative of the function inside. That's very complicated, but put simply, when we read that in English, we differentiate around the bracket remains the same, then we multiply by the derivative of the bracket. It looks complicated, but I promise you it is very, very simple. Example 1. Differentiate f of x equals 5x plus 2 cubed. Let's do the chain. So write down the function f of x equals 5x plus 2 cubed. Now we're going to differentiate around the outside of the bracket. So I'm going to cover it up. Now you can just pretend that is x cubed. So if I differentiate x cubed, I get the derivative equals 3x squared. So it's 3 brackets squared. I ignore the bracket just now. I just write it the way it was. I'm going to uncover, with my finger uncover the bracket, and the bracket says 3 times 5x plus 2 squared. I'm now going to differentiate inside the bracket and I get the number 5. Last step, I'm going to multiply them together. 3 times 5 is 15, so I've got 15 5x plus 2 squared. Easy. Now that's the way I always do it. However, in some textbooks there's a different, more formal notation. I'm going to introduce you to this once because it's used at advanced higher level when you're doing really complicated work. So let's have a look at it. So you could write down y equals 5x plus 2 cubed. And then we could say, well, let's simplify that. Let u equal 5x plus 2. Let u equal the bracket. Y equals u cubed. Now you need to know then that dy by dx equals dy by du times du by dx. This is exactly the same as multiplying outside the bracket and inside the bracket. It's just been more formalised. Okay, that then gives me dy by dx equals, okay, dy by du, differentiate y with respect to u, I've got 3u squared, and differentiating du by dx, differentiate u equals, I get the number 5, multiplying it out, that gives me 3 times 5x plus 2 squared times 5, which is 15. It's exactly the same, it's just been formalised. Now I'm not going to show you that again, but you'll see that in full detail in the textbooks or when you come on to advanced higher level. Example 2 then, back to basics. Differentiate f of x equals 2x squared plus 3x, and it's got a square root over the whole function. Okay, so I'm going to prepare that first. I'm going to take the square roots and I'm going to call that the power a half. So I've got f of x equals 2x squared plus 3x to the power a half. I can differentiate that now. So remember, outside the bracket, pretend that's just x to the power half. How would you deal with it? So I'm covering up the bracket. f dash x equals a half times the bracket, now to the power minus a half. So I've differentiated around the bracket. I'm going to uncover the bracket, it's just left the same, and I am going to differentiate inside the bracket. And that gives me, a bit more complicated this time, 4x plus 3. Last step, I'm going to multiply them together. Tidied up, that then gives me f dash x equals 4x plus 3 divided by 2 times your 2x squared plus 3x to the power negative a half. A bit more complicated. Okay, heading up for the exam standard now. Let's try some more. Example 3. A function f is defined by f of x equals 2 sine to the power 4x. Determine f dash of x. So f of x equals 2 sine to the power 4x. Now I always write it like this. I prefer to write f of x equals 2 sine x, that's the function, to the power 4. Now do your chain rule, cover it up, do outside the bracket. That's just like having 4x to the power 4. How would you differentiate that? So f dash x equals 8 times the bracket to the power 3. I'm going to unveil the bracket, it's sine x. I'm going to differentiate inside the bracket. Remember our table of standard derivatives? If I differentiate sine x, the derivative is cos x. So that gives me cos x outside the bracket. Okay, tidying it up, f dash x equals 8 sine cubed x cos x. Example 4. If y equals 1 over 2x plus 6 to the power 3, find dy by dx. Now what's your notation for this one? So first of all I'm going to have to prepare. So y equals 2x plus 6 to the power negative 3. Right, using our negative indices. Now prepare to differentiate. It should be easy. Okay, I'm going to differentiate around the bracket first of all, so I'm going to cover it up. So dy by dx equals minus 3 times the bracket to the power minus 4. Okay, I'll unveil the bracket and I differentiate inside the bracket. I differentiate 2x plus 6 and that gives me the number 2. Now I'm going to just bring it all together by multiplying it together. dy by dx equals minus 6 2x plus 6 to the power negative 4. And just to show off, I'm just going to leave that then as a positive index equals minus 6 over 2x plus 6 to the power 4. You wouldn't have to do that in the exam unless you're actually going to evaluate the derivative. At that point, you're going to have to put it into positive indices, but we may as well just improve our skills just now. Right, it's time to try these examples on your own. I want you to differentiate 1 plus 2 sine x to the power 4 with respect to x. That's 2 marks past paper. And then the next one is, given that g of x equals a half x squared minus 1 to the power 4, find the value of g dashed at when x is 2. That's a 4 mark past paper. So try it on your own, thinking of how SQA mark it. Pause me and then come back and get the answers a bit later on. Good luck! Okay, here's the answers according to the SQA marking schemes. How did you get on? Okay, so mark yourself 2 out of 2, 4 out of 4. Okay. If you've not got it right, look back. Where did you make your mistakes? Remember to ask for help when you come into class. Okay, pause me if you need to. I'm about to move on. Right, self-assess your progress. How did you get on today? Are you coping really well, green? Needing extra help, amber? Or really confused, red? If you're marking yourself red, you must ask for help when you come into class. For extra work on this, you can try page 280 of your textbook, exercise 14H. So what have we learned today? Well, you've learned the chain rule. Key steps to differentiate brackets with powers, use the chain rule. That's complicated to write that down, but remember what we said? Stated simply in words, differentiate around the bracket remains the same, then multiply by the derivative of the bracket. It's really quite simple.